Do you remember the different formulas that you're given, limits of trig functions? You remember the key formulas?
Um, yeah, like the limit of like sine x is 0, the limit of cosine x is 1, tan is 0, and all that stuff like that. And like sine
Uh,
x over x is 1, 1 minus cosine x over x is 0, and like it could be the reverse cosine minus 1 over x is 0. But yeah.
yeah. Yep. So one of the formulas for this one is the limit as x goes to 0 of sine x over x equals 1, right?
Hmm. Yeah.
So what we're going to do is we're going to do some algebra manipulations to make this look like that. We're going to do something to make this formula go red. We want that to look like this
Hmm.
by doing algebra. So the algebra that we could do, oh, are you still there?
Yeah.
Okay. I just turned off my iPad for some reason. Um, we have to try to turn the cube root of 3, the cube root of x into just x. And the way we do that is we would multiply this by the cube root of x squared, right?
Okay.
But if we're going to do that on the bottom, we also have to do that on the top. So this is the same as the limit as x goes to 0 of the cube root of x squared times sine x all over the cube root of x cubed. And of course, the cube root of x cubed is just what?
Um, X.
It's just x. So now we have what we want. That equals the limit as x goes to 0 of the cube root of x squared times the sine of x all over all over x, which equals, we can break this up, right? The limit as x goes to 0 of the cube root of x squared times the limit as x goes to 0 of sine x over x. Follow?
Hmm.
And this goes to 1. So it just equals the limit as x goes to 0 of that, which is just 0 times 1, which is just 1 or 0.
0.
Yeah,
Okay.
makes sense.
So the 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 X
Yeah,
um
you want to make it look like this by doing
mhm,
algebra. So the
yeah.
way I made it look like that is I multiplied it by basically the cube root of x over the cube root of x. So I'm sorry,
Mhm.
cube root of x squared over the cube root of x squared. Because remember, the cube root of x cubed is just x.
Yeah.
You understand that? So that's what we did there. For this number 14, we want to take and we want to rewrite this. What's cotangent equal to?
Tangent cotangent is cosine over sine.
So it's cosine x over sine x, right?
Yeah.
And we can kind of see what we're looking for right here, but it's flipped, right?
Hmm.
So let's flip it. Let's call that the limit as x goes to 0 of cosine x all over sine x over x, which equals the limit as x goes to 0 of cosine x all over the limit as x goes to 0 of sine x over x. Follow?
Hmm.
That equals 1. And what is the top of that equal what's the cosine of 0?
1.
It's also 1. So it's just 1 over 1, which is just 1.
Oh, okay. Oh.
So just algebra manipulations. You just got to kind of practice them, get them,
You div
you know.
you took the X from the cosine and brought it down.
Yeah, see what I did? I is I like I multi, you know how do you divide by a fraction? You multiply by the reciprocal.
Mm-hmm.
Well, you could also take a fraction and divide by the reciprocal. That's what I did there.
Mm,
Now, there might be other ways to do that problem because you might have already proven something about limit as x goes to zero of x over sine x. Do you have anything?
no, I don't think so.
Yeah, I don't think you do. I don't think they have that for you, but essentially you have, I mean, this now is a rule if you wanted to use it. The limit as x goes to zero of x times cotangent of x equals one. Now there's a rule for you
Yeah.
if you want to use that from now on, because that's always true.
Yeah.
Get it?
Mm-hmm.
So for this next one, that is looking to me kind of like the limit as x goes to zero of one minus cosine x over x. Remember that rule? Limit as x goes to zero of one minus cosine x all over x. What does that equal?
That would equals to one.
No, that
No,
equals
zeros.
zero.
Zero, zero, yeah.
Yeah,
Zero.
that's your other rule, your other big rule to use. And that's what that kind of looks like to me, right? So let's
Mm-hmm.
simplify this. See if we can get it. Limit as x goes to zero of one minus one over cosine of x all over x. Now let's multiply everything by cosine x, maybe on the top and bottom. So if I multiply everything by cosine x, I'd get cosine x minus one all over cosine x x. And I'm close to what I need here, right? That needs to just be flipped. You know the trick to doing that? Factor out a negative one. So
Yeah.
this is equal to the limit, excuse me, as x goes to zero of I'm gonna I'm gonna keep this with that, and I'm gonna keep the negative one with the cosine of x times whoops times one minus cosine x all over x. Got it?
Mhm.
Which equals the limit as x goes to zero of negative one over cosine x times the limit as x goes to zero of one minus cosine x over x. And what do we know about the second thing here?
The second one, the one minus cosine x over x equals zero.
Right. And so it doesn't really matter. This equaled negative one, but it doesn't really matter.
Yeah.
That's negative one times zero, which is just zero.
Okay.
Got it.
Yeah, makes sense.
Do we have a tan sine formula that we know?
Uh, uh, I know that the tan x equals zero, and from what I've seen, tan is basically the same as sine from how my teacher explains it. So sine x over x is the same thing as tan x over x.
Okay. Okay. I think I understand what you're saying. So what we want to do for this one then, the trick I think I would employ for this one is multiply the top and bottom by 4x. You'll see why. Okay. And
Mhm.
then combine these two together. So that's the limit as x goes to zero of tan 4x over x. Oh, sorry, over 4x times, and then combine these other two together. You know what I'm doing?
Yeah,
With just 4x all over sine 4x.
which is basically the same as if it was flipped.
Right. Which then I can just write 1 over that, right?
Hmm.
So I could call this 1 over sine 4x over 4x, right? And remember, I can split the limit up now. The limit as x goes to zero of that, and and then the limit as x goes to zero of that. And each of those goes to what, one?
Yeah.
Yeah, each of those goes to one. So this goes to one, this goes to one, which is 1/1. So it's 1 times 1, which equals 1. Make sense?
Yeah.
You have the answers for these?
I'm pretty sure I do. Let me double
Yeah.
check.
You
Yeah.
just double check them to make sure that we're getting them right because I don't
Mm-hmm.
have the answers to these and I haven't done these yet this year. So it's a little new for me, but this is, yeah, it's basically just what I'm showing you,
Mm-hmm.
right?
Yeah.
You're using trig. You're using trig. So for this one, let's see if we can, what is the cosecant of 2x?
That
It's
would,
1 over sine
yeah,
2x.
one. Yeah.
Limit as x goes to 0 of 1 over the sine of 2x all over. Let's rewrite cotangent just into cosine over sine because it's probably going to be helpful for us, right? So this equals the limit as x goes to 0 of 1 over, let's call that 2 sine x cosine x, right?
The double
Times,
angle.
yeah, yep, remember that formula?
Mm-hmm. Yeah.
Times, let's flip the other one on the bottom, sine x over cosine x now. And now I can cancel out the sine x. So I just get the limit as x goes to 0 of 1 over 2 cosine squared x. And don't overthink these. Can I plug in 0 for cosine right now, or for x right now?
Um, technic
Sure.
technically,
That just equals 1 over 2 times cosine squared of 0. What's cosine squared of 0?
one squared, which is just one.
Yep. So it's just cosine of 0 squared. I'll write it like that, which
Okay.
equals 1 over 2 times 1 squared, which just equals 1 over 2. So that one we didn't even have to use any trig limits. We just simplified it, and then we were able to plug in it and plug in. Anytime you can plug in the value, plug it in.
Yeah.
But see, for these, you can't plug in 0, right? That won't get you what you need.
Yeah.
That'll give you an indeterminate. Okay.
So from what I've seen, like the major points is like knowing like the foundations, like the limits of cosine's one, the limit of sine is zero, and all that stuff. Break it down to smaller bits and pieces, and then see if you could plug in the zero or just
Yeah. Yep.
okay.
Or if you, like I said, if you memorize, like you told me, that tan x over x is also the limit as x goes to 0. That's the same as the sine,
Okay.
right? So you can use that once your teacher might say, hey, use this one as a formula. Use this one for a formula. But like I said, once you establish this, if you want to use this, you can just be like, hey, that equals 1 all the time. The limit as x goes to 0 of tan something over sine of that same something is always going to equal 1. That's a new formula that you
Mhm.
can use once you've established that that's true.
Yeah. I wish it was simple like that, but
Right.
he
Well,
he
yeah, you don't want to memorize 50 formulas.
yeah,
So what you
and
do is you just memorize a couple and you always use those ones, right? You
mhm,
always go back to
yeah.
that one.
hmm And he's having it where like we have to show every step or like most steps. So even so, like
Yeah.
we know
Yep.
that if like sine 2x over 2x is like
Yeah.
1, why is it?
Right. Sine 2x over 2x equals 1. That's a property that you can use. I don't think you have to prove that. I think that's one of the properties that you can
Yeah, yeah,
that your teacher
it
lets
it,
you stick with.
it is, but um even
But you
like
have
if
to
it's just
show
one
how to
step.
get to that point. Yeah, you have to
Yeah,
show how to get to that point. Right.
yeah.
It's kind of like sine squared plus cosine squared equals 1. You don't have to prove that every time.
hmm
You've established that, and your teacher's basically like, hey, you can use this whenever, you can use this as already having been proven.
Mm-hmm.
Kind of like Pythagorean's theorem. You don't have to prove it every time you get a right triangle. You can just understand that that's true for every right triangle.
Mm-hmm.
So these are called theorems, right? Theorems are formulas, basically generic formulas that have been proven to be true in all situations.
Mm-hmm.
So, all right.
Yeah.
You got
Well,
another question, or is that it?
I think those were like the hardest complex ones I was given. And he's given us the quiz like in the last 10 minutes of the period, and apparently it's just like five questions, but I really do need this quiz grade. So I'm pretty sure like the first like 30 minutes he'll allow us to review, but then test that then he'll pass out the quiz. But I do think that this gives me more like knowledge or like a better understanding of it.
Yeah, good. All right. Well, good
Yeah,
luck with it. You can watch that video again on YouTube. Okay.
perfect.
All right. See you, buddy.
Yeah, thank you.